Alright, so this is the first video on linear programming, and this is probably a topic that is new to you. I believe we don't go over this in Algebra 1 and definitely not in Geometry. But basically the idea behind this is you're given what we call an objective function, so some sort of function, and what we want to do is we want to find the maximum and minimum values. And so this could be used for things, we want to maximize the efficiency of a shipping company, or we want to minimize the cost it takes to do something. But we have certain constraints. We can't do whatever we want. There's certain constraints on what we can and can't do. So those kind of limit what we can do. So we don't get into very complex linear programming. We do basic stuff. But basically the idea here is they give you an objective function, and so the objective function, if you read the question, it says find the minimum and maximum value of the objective function subject to the given constraint. So the objective function, right, is always going to be this one right here. C, let me stop highlighting everything. C is equal to, so whatever C is, that usually says C is equal to, that's going to be your objective function, okay? And then it says subject to the given constraint. So these are the constraints down here, and your constraints are always going to be inequalities. And sometimes there's 3, like in this case, but sometimes there's also going to be 3, 4, or 5. There's really no limit on how many there can be, but usually in the cases in this class, you're going to see 3 to 4. Okay? And basically the idea behind this is you're going to graph these inequalities to give you an idea of what area, of what points you're allowed to use these constraints. So basically the idea is, we want to figure out what maximizes this function. What two x and y values maximize this objective function? But if you think about it, like, well, 1 million for x and 1 million for y would make it very large. But you could just keep coming up with larger and larger numbers. 2 million for x and 2 million for y, that would make it even bigger. But if we would just go on for infinity. So what we do is we have these constraints, and they tell us what values we can plug in for x and y. And so we want to graph them to visually see which values we're actually allowed to pick to plug in this function. And then from those values that we're allowed to pick, then we can make figure out what our max and what our min is going to be. So the first step is to graph these inequalities to see which values we can plug into our objective function. So let's start off by graphing this one. X is greater than or equal to 0, and let's see what we do. So x is greater than or equal to 0. That's a vertical line. So let's draw it right here. So the red line is this function right here. So x is greater than or equal to this one. So greater than, so it's greater than x. So it's going to be all the positive values. It's going to be in this to the right of the red line. Okay. And y is greater than or equal to 0, so that's a horizontal line, and then we draw it down here. Okay, and so we have greater than x, so that's this way, right? And we have greater than y, so that's going to be up this way. So the not down there. Okay. These two functions constrain it to the first quadrant. That's what these two functions, or these two inequalities, are doing first. They're constraining it to this first quadrant. But there's still no limit. We need some kind of line here, or somehow to stop these. Otherwise we could just keep going on forever in this direction, right? So we need to constrain it by one more line. So this last one here is the third constraint, and hopefully that kind of blocks it off like that. And so what I recommend doing for these is make sure they're always in y equals mx plus b form, right? So we can graph them. So let's first start off by doing that. So if I want to solve this, I will subtract x, right? And so we'll get y is less than or equal to negative x plus 8. Okay? And so if I was going to plot that, I would just go up here and I would go to 8. So I got 2, 4, 6, 8. Right, there's my y-intercept, and then my slope is negative 1, so I'm going to go down 1, over 1, down 1, over 1, down 1, or sorry, down 1, over 1. Right, and that should give me a good enough line right now or enough points to draw a pretty accurate line. So let me just kind of, it's going to be right there. Let me change this up here. So there you go, that's pretty good. And so let's look at where this shading occurs, and so we'll use a different color. So it says y is less than, so when it's less than, that means it's below the line. So that's going to be all this area. So this is inside that triangle there is where our function is constrained to. All these little points in here, right? There's infinitely many points in here. Let me get a color that shows up. There's infinitely many points within here. So we don't want to check every single one of these because that would take us forever. So there's only certain points that we need to check. Okay, and those points are always going to be the vertices of this shape that your inequalities form. So in this case, it formed a triangle. Right here, you see this triangle, and so the only points we need to plug into our function, to our objective function, are the three vertices. So this point, and that point. And then from those 3 points, that will tell us, what the maximum value is and what the minimum value is. So your next step, once you graph these inequalities, is to find all the vertices and then plug each vertex into the objective function and see which one gives you the largest value and which one gives you the smallest value. So let's start off right here at the origin. So this point right here is 0, 0. All right, and so we plug that in, right, and so we would get c is equal to 3x, or 3 times 0 plus 4 times 0, right, and you probably already know this is going to be c is equal to 0. Okay, so that's might be our minimum. Who knows? Let's try the other ones. This point right here is 8, right? You go 2, 4, 6, 8. That's 0, 8. Okay, and so that's going to be c is equal to 3 times 0 plus 4 times 8. Yeah, that's a 4 right there. So 3 times 0 is 0. 4 times 8 is 32. So this is c is equal to 32. Okay, let's try the last one here. And so we got 2, 4, 6, 8. That's also an 8. So this one is 8, 0. And so let's plug it in here. And so we're going to get c is equal to 3 times 8 plus 4 times 0. And so 3 times 8 is 24. And 4 times 0 is 0. So we get c is equal to 24. All right, and so let's look at our values here. We have 32, 24, and 0. So we're trying to find the maximum value, and the maximum value is probably going to be 32. Yep, it's the largest one. And then the smallest value, the minimum value, is going to be 0. Okay, 0. So that's the first video on linear programming. The second video is going to be a similar problem. It's just going to be a little bit more difficult. The constraints are a little bit more difficult, more similar to what it's like on the test. So if you aren't feeling confident with this, either rewatch this video or move on to the second one to get a better idea of how to do this. Okay?